Hello and good evening. This is our project proposal paper that we have submitted. Now I'm going to demonstrate about my project. That is air quality monitoring using Raspberry Pi 4 and SPS 330 SPS 30 sensor. We are from group 6 and these are our group members. So these are the contents and I'm mainly going to talk about the introduction part. So what our project does, it has been made for, and what it can do. So what our project does is that it is an air quality monitoring project that is with the help of using a Raspberry Pi. It detects and a sensor. It detects the air quality, gives us the read through and cloud platform, and we can get the readings and we can see which air quality is bad and which air quality is good. So what is the purpose of making this project? So mainly we are living in the industrial era, and due to the advancement of industries, our climate is getting affected drastically and it is degrading day by day. So as a result of this, our air is getting polluted. So in a healthy air there is 21% oxygen and 78% nitrogen and 1% argon, but in a bad air there are much more greater percentage of nitrogen and lesser percentage of oxygen, and different harmful particles are present in it which are causing lung cancers and different lung diseases. So in order to minimize those things and avoid those things, our project can be used to monitor the air quality of any indoor, outdoor, any environment it can. So it basically uses a carbon dioxide sensitive sensor and a SPS 30 sensor and a Raspberry Pi and a breadboards and jumper wires. So these things altogether gives us the read of any air, particularly in any indoor or outdoor condition or in any industrial or factory condition. So what our project can do is that by using those readings, one can differentiate between the bad and good air quality and can reside on the good air quality areas and can set up factories and other machinery things on the bad air quality regions. So that this is from me now, and the next word will be described by my group mates.
Assalamu alaikum. I am Ahnaf Morshed Maruf. My ID is 20101630. I am gonna talk about the components that we have used in our air quality monitoring project using Raspberry Pi. Raspberry Pi is the main hardware component in our project. It's a mini computer because it contains microprocessor. It also contains some GPU pins to control the sensors and to connect with the circuits that are used in the project. We have used a breadboard to build the necessary circuits. It's a very user-friendly component which can be carried easily and removed or replaced easily. We have used different sensors like Sensorion SPS 30 for Raspberry Pi to measure the air quality of a particular place. We have also used a PM2.5 ppm sensor to monitor the air quality for indoor and outdoor environment. It's mainly used to collect formaldehyde, ammonia, benzene and total volatile organics. We also used a COPPM sensor which is highly sensitive to carbon dioxide. And lastly, we have used some jumper wires to build our circuits in breadboard and to connect the sensors with the Raspberry Pi. For softwares and online services, we used Python as our primary programming language. We used Microsoft Azure as cloud platform to use the database services and other services offered by it. We used an open source collaboration project named Yocto project to create a custom Linux based system for embedded products. That's all from me. Now further discussions will be delivered by my fellow teammates. Thank you.
Hello, Assalamu alaikum, sir. I'm Shafkat Zahir, and I did the connectivity and working procedure part for our project proposal. I will explain the working procedure first. We have to configure the Raspberry Pi, and we have to use the Yocto project. Yocto is a set of tools for building a custom embedded Linux distribution. Then in step 2, we have to clone some files into our Raspberry Pi. Then we have to copy the image to the SD card, and then we have to proceed to the image modification. First, we add our path. We have to run several commands to acquire some extra space, enable I2C, and install extra packages. We need to add our path to meta layers too. We require few extra modifications, such as finding out the exact time, install Rust language, initializing the NTP service, setting up the time zone and Wi-Fi configuration, etc. We have to run these mentioned commands to proceed further. Now I will explain the connections established in our proposal. Uh, First, we need a Pi SPS30 sensor to 10 kilo ohm resistors and a breadboard. We have connected the VDD1 of SPS30 sensor to 5-volt power of the Pi, SDA to GPIO2 and SCL to GPIO3, and SEL and GN ground of our SPS30 is connected to the grounds of Raspberry Pi. We should verify the connections by running this command. I have attached a picture of the Raspberry Pi pins for reference. To read the data, we need all the Rust drivers installed and run the command cargo run. By following these measures, we can implement our project. My teammates will further explain how they will be fetching the output. Thank you so much, sir, for listening.
So now again, I'm going to talk about the result portion of our presentation. So there are a comparison of two cities. The left one is a air with no pollution, right one is the air with pollution, and a comparison of the same two cities. So how do you get the numbers, the graphs that we're going to see in the future slides? So basically we're getting the numbers, the graphs, the values from the Microsoft Azure platform, which is an IoT based cloud platform, free to use. So from the Azure service tab, we go to the resource to obtain and view the values in form of graphs and other charts. So these are the values sent by the IoT platform that we are using, the platform that we're using, that is the Microsoft Azure. So our Raspberry Pi connects with the sensor. Our sensor takes the reading from the outdoor and indoor situation of any particular air, gives those readings to the cloud platform. The cloud platform then send us those readings in form of graphs and values that we are seeing in the table 1. This is the values of air quality using different sensors, that is the SPS30, PM2.5, CO sensors that our groupmate previously described about. Table 2 is the Raspberry sensor using those same sensor in the morning situation. These are the readings, and these are lastly this is the cumulative these are the values provided by the IoT based platform by Microsoft Azure. We can so that we can see it, what condition and what pressure that air has, what humidity or and what the temperature is. And this is this picture is taken here from a research paper that we have read, and this is how we can understand how the saturations and different ozone layer percentage is in the air. So these are the readings from it, and these are the demonstration that we have already written in our project proposal. This is from me now. And lastly, this is the graph that I was talking about earlier. So we can here see that it is considered that the less the PM value, the more the healthier it is. So if a PM value that is 2.5, less than 2.5, it is considered healthy. So 1.06K is considered healthier, and these two are the graphs earlier from the pictures. Thank you. The next part will be demonstrated by my group mate.
Greetings, this is Tausif Ahnaf, and I'm going to be talking about the future improvements of our project Air Quality Monitoring using Raspberry Pi 4. For now, it is only embedded to a Raspberry Pi with a couple of jumper wires and an air pollution sensor known as Sensirion SPS30. Using this, and from Microsoft Azure cloud support, we can monitor this, but it is only terrestrial. It will be more beneficial if the system is embedded into flying drones, then we can really use this at any location from aerial position, and that is where air monitoring would be much more efficient. Another improvement that can be made is that with some advanced boards to connect the circuit, then we don't need a breadboard. It can be connected to a good solid advanced board inside the circuit and it could perform flawlessly anywhere at any time without getting touched from outside object or any kind of external force. And if there are any other improvements that would be possible for this project, then I would suggest software and online services, like we are dependent on Microsoft Azure and Yocto project. But who knows, there might be better softwares in the future and it might make our project much more efficient and less time hungry. Thank you.